In this module, we're going to cover how to classify triangles and quadrilaterals that are in the coordinate plane. This video in particular is going to focus on classifying triangles. Here we can see that there are different properties of triangles that make one unique. We can look at characteristics such as the side lengths and the angles to be able to determine which type of triangle we have. Triangles can have multiple classifications. They can fall into our first category, so be seen as scalene, isosceles, and equilateral. And they can also fall into our second category, which means that they can be seen as right, acute, and obtuse. Let's start to see what makes each type of triangle unique. A scalene triangle is a triangle where all sides are different lengths and all angles are different measures, meaning that this could be 2 units, this could be 7 units, then this one could be 6.5 units. An isosceles triangle is a type of triangle where at least 2 of the sides are congruent, which makes the angles across from one another also congruent. An equilateral triangle is a type of isosceles triangle where all 3 sides are congruent, which means that all 3 angles are also congruent. Now that we have those, let's go on to right, acute, and obtuse triangles. So a right triangle is a triangle where we have a 90-degree angle. And the way that we can prove this, hopefully we know, is by using the Pythagorean theorem. But the Pythagorean theorem can also be used to prove that triangles are acute and obtuse. So an acute triangle is a triangle where all angles are less than 90 degrees. And we could use the Pythagorean theorem in the sense that if the sum of the squares of the shorter sides are greater than the square of the longest side, it'll be acute. For an obtuse triangle, that means one angle is greater than 90 degrees. And the way that we can prove that using the Pythagorean theorem is if the sum of the squares of the shorter side are smaller than the square of the longest side, meaning that the longest side dominates. We'll see an example of all of these in just a second. So remember that triangles can have multiple Remember that triangles can have multiple classifications, and we're going to go ahead and figure out which categories this type of triangle will fall into. So the way that we would start this off is by first figuring out what are all the side lengths. And the way that we can do that is in one of 2 ways. So the first way is we could use the distance formula from last week. If that's what you prefer, perfectly fine. Or we could use the Pythagorean theorem, our altered version, and that's what I'm going to be using for today. So the first line segment I'm going to go ahead and find is line segment EF. It's the easiest one. It's a vertical line, and this is going to give us 6 units. Then we're going to go ahead and find DF, and remember we do that by creating a right triangle. This is 3 units, and that's 6. So that's going to give us the square root of 3 squared plus 6 squared. And then we'll do the same thing for DE. And DE is going to give us, this is 3, and this is also 6. So 3 squared plus 6 squared. When we estimate the value of these, because it's not going to be exact, this will give us 6.71 units, and so will this one. So now that we found the side lengths, I'm going to go ahead and write them down on the triangle. And we're going to see what type of triangle this is based on what we've calculated. So remember that a scalene triangle has 3 sides that are all different. Isosceles triangle has 2 sides that are the same. An equilateral has all sides that are congruent. Looking at this, we can see that this side and this side are congruent, which means that this is going to be an isosceles triangle. Great. So now that we did that, now we're going to see if we have a right triangle, an acute triangle, or an obtuse triangle. And the way that we do that, as mentioned before, is by using the Pythagorean theorem. Now you're going to see that this looks a little different than what we usually do because there's no equal sign. The symbol that goes in here is dependent on what happens once we plug our numbers in. So remember, these are the shortest sides and this will be the longest side. If this value is equal to this value, it's a right triangle. If this value is greater than this value, it's an acute triangle. And if this value is less than this value, it's an obtuse triangle. So let's go ahead and try it. So our A is going to be our shortest side, so 6 squared. And then these sides are the exact same, so it doesn't matter where you put them. And we want to figure out what symbol is going to go right here. So when you're evaluating these, we're going to do it a little differently. You actually want to get whole numbers. The reason for that is because since we've been rounding so much, we've been losing little numbers here and there. Whole numbers will hopefully make everything right. So when you evaluate this, this is going to give you about 81 units, and this one's going to give you approximately 45 units. We can tell that 81 is clearly greater than 45, which means that we're going to have an acute triangle. And to be honest, you can tell by looking at this that these are all acute angles. If you can tell, awesome. But I just want to make sure that you could see the process behind it. So now that we have that, we're going to write the type of triangle. So we have an acute isosceles triangle. And that would be the classification. Let's go ahead and try one more example. So we'll go through the exact same process that we went through in the first example of figuring out what type of triangle this is. So again, remember the first thing that we have to figure out are these side lengths. And the way that we do that is by using the distance formula or the modified Pythagorean theorem. So let's start with line segment HI. Line segment high. All right, so this is 2, and this is 1, 2, 3, 4, 5. So this will be the square root of 2 squared plus 5 squared. And I'll do all the calculations at the end. Let's go ahead and find this one. So this is IG. So this is 1, and this is 11. So IG, or GI, 1 squared plus 11 squared. So that's 3, and this is 6. So this is GH. So 3 squared plus 6 squared. All right, so we're going to get all of our approximate values. This one's going to be approximately 5.39 units. This one's going to be approximately 11.05 units. And this one's approximately 6.71 units. So I'll go ahead and write everything here. And then 5.39. All right, so based on this, first we want to figure out if this triangle is a scalene, isosceles, or equilateral triangle. We can see that all side lengths are different, meaning that we're going to have a scalene triangle. Do this in blue. All right, so now the next thing we want to try to prove or see is if this is going to be a right, acute, or obtuse triangle. I can clearly see the answer looking at this, but we're going to go ahead and try it just to make sure that you're okay with it. So remember that the way that we do that is by using the Pythagorean theorem. So a squared plus b squared something, c squared. So remember that these are our two shortest legs, two smallest numbers, and this will be our largest number. And we want to see if it's going to be right, acute, or obtuse, and we do that by looking at our symbols. So here we'll put 5.39 squared plus next shortest one is 6.71 squared. Then the last one is 11.05 squared. So remember that we need whole numbers. And when we do the calculations, this should be about 66 units, and this should be about 122 units. Now we can see that this value is clearly smaller than this one, so we're going to have a less than symbol, meaning that this would be an obtuse triangle. And again, I think you can see that just by looking at it, because this angle is way bigger than 90 degrees. So based on this would be an obtuse scalene triangle. And that's the method that you would use to try to classify triangles.